All right, welcome to the deep dive. Today, we're tackling a topic that I think has captured pretty much everyone's imagination at some point: time travel.
Absolutely. It's one of those concepts that just seems to fascinate us. The idea of moving through time, visiting the past or the future. It's mind-boggling.
Yeah, and for this deep dive, we've gone through a ton of sources, research papers, theories, even some science fiction to try and understand if it's even remotely possible and what the implications might be.
We're looking at everything from Einstein's theories to some of the latest experiments in quantum physics.
Right. So for our listeners, we're aiming to make all of this complex stuff about time travel as clear and engaging as we can. And who knows, maybe even a little mind-bending along the way.
That's the fun part.
So let's start with, I guess, the foundation of it all, which would have to be Einstein's theory of relativity. This is where things start to get really interesting.
It is because Einstein basically blew our minds by showing us that time isn't this absolute unchanging thing we always thought it was.
Right, like think about astronauts on the International Space Station. They're orbiting Earth at incredibly high speeds, right?
Exactly. And because of that speed, time actually passes a tiny bit slower for them compared to us here on Earth.
So they're basically traveling a little bit into the future.
It's a tiny, tiny shift, but it's a real measurable effect called time dilation.
Wow. So just by moving really fast, you can actually experience time differently.
That's the implication, and that's what Einstein's theory tells us.
Okay, so that's time dilation, but then our sources start talking about even weirder stuff like wormholes. I mean, it sounds like something straight out of science fiction.
It does, but it's a concept rooted in theoretical physics. The idea is that you could have these, well, shortcuts through space-time. Imagine folding a piece of paper so two distant points touch. That's kind of what a wormhole would be like.
So you could theoretically travel vast distances in an instant, or even like travel through time.
That's the theory. And some physicists, like Kip Thorne, have done a lot of work on what it would take for a wormhole to be traversable, for something to actually pass through it.
But isn't there something about needing some kind of exotic matter to keep them open?
Yeah, that's one of the big challenges. We're talking about matter with properties we've never actually observed, like negative mass, which would basically repel gravity instead of being attracted to it.
So basically, we don't know if this exotic matter even exists.
Not yet. So while the math of wormholes might work out on paper, the practical hurdles are, well, immense.
Okay, so we've got relativity, wormholes, and then we get to quantum mechanics. And it feels like we're entering a whole other dimension of weirdness.
We are. Quantum mechanics deals with the really tiny stuff, the subatomic world, and down there the rules of physics get really strange.
I read in one of our sources about these things called closed time-like curves, where particles might actually be looping back in time at the quantum level.
Right. And there have been experiments at CERN, the particle physics lab, where they've observed effects similar to time dilation, but on a tiny scale.
So it's almost like the closer you look at the universe, the more time seems to become this fluid, bendable thing.
Exactly. The idea that time is fixed and absolute really starts to break down.
Okay, but even with all these wild possibilities, our sources also lay out some pretty big roadblocks to actual time travel.
Oh yeah, tons of them.
Yeah.
Even if we assume that the physics allows for some kind of time manipulation, the technology and the energy needed would be astronomically beyond anything we have today.
And then you've got all those famous paradoxes, like the classic grandfather paradox. What happens if you go back and prevent your grandfather from meeting your grandmother?
You'd erase your own existence, which wouldn't make any logical sense. That creates this unsolvable loop.
Right, and there's that other one, the bootstrap paradox. Like, imagine finding a book detailing future scientific breakthroughs, but there's no author listed.
You take it back in time and publish it yourself, becoming the author.
So where did the information come from in the first place? It's like a circle with no beginning. These paradoxes really make you think, well, maybe the laws of physics somehow prevent us from doing anything that would create such contradictions.
It's a fascinating thought.
And maybe that's why we keep coming back to these ideas in movies and books. It seems like we can't let go of our fascination with time travel.
I think it reflects our desire to understand time better, our place within it, and maybe even a little bit of a hope that we could control it somehow.
You've got movies like Interstellar, which delves into relativity and wormholes, and then you've got Back to the Future playing around with paradoxes and alternate timelines.
They capture our imagination and make us think about the implications of time travel,
Mm.
even if it's just in a fictional setting.
So to wrap up what we've learned from all these sources, even though the physics, especially relativity and quantum mechanics, might offer a glimmer of possibility, the practical and logical challenges to actually traveling through time are, well, pretty much insurmountable for now.
For now, yeah. And we have to remember that even though astronauts experience time dilation, it's a tiny effect. It's not like they're hopping back and forth through centuries.
It's a real-world example of relativity in action, but it's a far cry from stepping into a time machine.
But the fact that our understanding of time has evolved so much, from something absolute to something that's interwoven with space and motion, that's a huge leap forward.
It is, and it leaves us with a final thought to ponder. Even if somehow, someday, time travel did become possible, should we even try it? What kind of responsibility would come with that power, knowing that even the smallest change to the past could have massive unintended consequences?
It's a question that goes beyond science and touches on ethics, philosophy. It's something worth thinking about.
Definitely. Anyway, thanks to everyone for joining us on this deep dive into the mysteries and complexities of time travel.
It's been a mind-bending journey.
It has. Until next time.
See you then.